Cape Canaveral in Florida. This is Falcon Launch Control at T-minus 1 hour, 14 minutes, 28 seconds and counting. The countdown for the launch of the Falcon 9 with the Dragon capsule bound for a rendezvous with the International Space Station is on schedule for a liftoff at 3:44 a.m. this morning. Pre-launch activities have been underway at Space Launch Complex 40 on Cape Canaveral Air Force Station since 8 o'clock last night, at which time the Falcon 9 and the Dragon capsule were powered on. Shortly afterwards, there was a vehicle verification with the Tracking and Data Relay Satellite System, as well as the Ground Tracking Station network. Then the call to stations for the SpaceX launch team in preparation for fueling occurred at 11:35 p.m. This is the terminal phase of the countdown, which is 4 hours and 10 minutes in duration, and there are no built-in holds. Loading of liquid oxygen began at 11:55 p.m., and the RP-1 fuel followed 10 minutes later at 12:05 a.m. There was then a test of the first motion sensor in preparation for the liftoff at 1:14 this morning. The S-band telemetry and video transmitters on the rocket have been checked out, and the flight termination system checks with the Eastern Range have now been completed. Upcoming at T-minus 1 hour will be a weather briefing with Launch Weather Officer Mike McAleenan. The launch computer's automated terminal countdown sequence begins at T-minus 10 minutes. After liftoff from Complex 40, Dragon will begin its journey to the space station. Just under 10 minutes after launch, the capsule will reach its preliminary orbit, deploy its solar arrays, and begin a carefully choreographed series of engine firings to rendezvous with the station. At T-minus 1 hour, 12 minutes, 30 seconds and counting, this is Falcon Launch Control. This is Falcon 9 Launch Control at T-minus 1 hour, 9 minutes, 32 seconds and counting. We're joined here in the Launch Control Center by Alan Lindenmoyer. Alan is the NASA COTS Program Manager from the Johnson Space Center in Houston. And we've asked Alan to maybe tell us a little bit what the ISS Mission Control Center in Houston has had to replan for a launch tonight, and where we go from there. Alan, welcome.
Thank you. Good morning.
Tell us what's been going on and what's coming.
Well, I think you can imagine space station is moving quite rapidly up there, and there's been a lot of coordination to be sure we know exactly where the space station is, so this Dragon can go and berth and meet up with the space station. So that's been a great deal of effort over the last few days, just to be sure we have been coordinating the precise locations of the station, replanning each of the events leading from launch leading up to the berthing with the station. So teams have been working really hard getting that replanned. It looks like the basic timeline is still the same. With the launch this morning, the Dragon will be phasing over the next 24 hours, making its way toward the space station. And then on the second day, the 24th of May, we should see the Dragon getting close to the station, doing its flyby, checking out the comm systems and its other systems as it passes underneath the space station. And if all goes well, it'll do the re-rendezvous, and on the 25th, then, it should be Friday, we should see the station, the Dragon, doing the final approach to the station. So they've been tracking carefully the new trajectories and burn plans to have everything line up, and it looks like that's the way that's going to work out.
So at this point, I gather we've just simply toggled a little bit to the right. When if we launch this morning, when would that make the splashdown, the end of mission?
Right, so the plan is to actually hold the splashdown date as May 31st. So the crew on orbit is going to be extra busy unloading the Dragon with its complement of cargo that it's bringing up. It's bringing up a little over 1,000 pounds of cargo, and then they'll be busy repacking the Dragon to bring some experiments and equipment back home for us. So that's been compressed a bit. The target is to do the unberthing and the reentry, holding that on May 31st.
All right. Well, thank you, Alan. It looks like everything's on track here and on the space station and at mission control. So if our countdown continues to go well, which it is at this point, I gather things have gone quite well since we picked up with fueling.
Things are looking good this morning. Everything's checking out really well.
So we're at T-minus 1 hour, 6 minutes, 6 seconds, and counting. This is Falcon Launch Control. This is Falcon Launch Control, T-minus 1 hour, 1 minute, 46 seconds and counting. We've just released another weather balloon to check the upper level winds. Our launch weather officer, Mike McAleenan from the 45th Weather Squadron, will be briefing the launch team in just a couple of minutes.
Loads, this is Cape Winds on Weather BriefNet.
Go ahead, Cape Winds.
We have on-time release of HR6.
Copy, thank you.
Cape Winds out.
T-minus 1 hour, standing by for a vehicle release final setup at T-minus 40 minutes.
This is the LWO with the L-minus 1 hour weather briefing. Looking at the video, you can see what the remnants of Tropical Storm Alberto, now Tropical Depression Alberto, off the coast of South Carolina. And the track should take it up towards the north and east at about 10 knots, but it is losing intensity rapidly, and it is not expected to survive more than the next 48 hours or so. Looking at the water vapor image, you can see the result of this dry air across the northern half of the Florida Peninsula is resulting with some great weather and very few clouds in the northern half of the peninsula. Zooming all the way in, you can see very, very few clouds, just a few scattered low clouds around 2,500 feet approaching the Gulf Stream, and some very upper-level clouds near Lake Okeechobee associated with subtropical jet stream down to our south. Not really a threat at all for any kind of a launch constraint, and weather's looking really, really good. Radar shows no echoes within 150 nautical miles. Looking at the launch pad conditions, winds have picked up a little bit with a bit of a land breeze. We're looking at around 10 knots or so at 162 feet. As you can see, after sunset, with northeasterly flow with the sea breeze today, we have worked our way around, and now southwesterly winds at 240 degrees, and expected to remain that way through the rest of the countdown. When that wind did switch, we also dropped about 3 degrees in temperature, now at around 73 degrees, and again, expect that to continue. Right now, we are go for all range constraints and user guidance. We're tracking no problems for the weather. Forecast for T0, much of the same. Few clouds at 2,500, maybe some of that jet stream cirrus at 25,000. Unrestricted visibility, winds out of the southwest at 10 knots, and temperature around 72 degrees. So looking real good, tracking no issues, and that's all I have unless there are any questions.
This is Falcon Launch Control, T-minus 51 minutes, 23 seconds and counting. Joining us once again here at the Public Affairs Console is Gwen Shotwell, the president of SpaceX. And Gwen has been very busy the last couple of days working with the team to turn us around for launch tonight. So, Gwen, first of all, tell us what the problem actually was.
We found a check valve, a purge check valve, normally used for nitrogen, had stuck open. This allowed, when we start adding oxygen, liquid oxygen to the engine, this allowed that liquid oxygen to flow back through that nitrogen purge line into the gas generator, which actually gave some additional power to the engine. That's why we're seeing the increased temperatures and the increased pressure.
And so then the launch computer, I gather, did exactly what it's supposed to do. It said stop.
That's correct. The computer and the software did exactly what it was supposed to. It was trending high, and it shut it down, which was good. It looks like we probably could have flown with the condition. Once we separated from the ground, things would have settled down a bit, but it was still the right thing to do.
Well, how was SpaceX able to fix this problem so quickly? Because if we turn around and here we are again tonight, it seemed quickly to work an engine problem.
Yeah, our team is really fast. I think probably the reason is that the engineers do the work themselves. We don't have a lot of subcontractors and levels of subcontractors that would have to understand what the issue was and go back and look at data. The engineers that designed it and tested that engine were here, and as soon as the pad was safe, they got up and started looking around and found the problem. It was pretty obvious.
From your perspective, after we lift off, and particularly after Dragon is separated, what are going to be the first maybe one or two things that you'll be watching for most closely from your perspective that are going to be of interest to indicate everything is going well?
The most important thing is to get our solar arrays deployed. This would be the first time we've done that on orbit. We do it hundreds of times in the factory, but that's not really where it counts. And that occurs almost immediately after separation, within a couple of minutes. So that'll be a key element of this flight.
All right, Gwen. Well, thank you very much, and best of launch tonight. And we'll see you again at the post-launch news briefing.
Great, George. Thanks.
Thank you. And we're at T-minus 48 minutes, 37 seconds and counting. This is Falcon Launch Control. This is Falcon 9 Launch Control, T-minus 44 minutes, 24 seconds and counting. About 4 minutes from now, we'll hear the launch team begin to put the Falcon 9 into the final configuration for launch. It will take about 20 minutes to do before they go into their final launch countdown preparations. So we'll hear that activity very shortly. For the first time in history, a private corporation is set to prove that it can deliver cargo to the International Space Station. Two companies are contracted with NASA for that mission, SpaceX and Orbital Science Corporation. Both been working for the past 6 years to meet this objective under NASA's Commercial Orbital Transportation Services Program, known as COTS. These two companies will resupply the space station for NASA through 2015. The first COTS demonstration flight was successfully completed by SpaceX in December 2010, where it proved the Falcon 9 rocket could launch, then orbit, and recover its Dragon spacecraft. When this mission is over, the Dragon will splash down in the Pacific Ocean off the coast of California on May the 31st. The Dragon capsule on this test flight will transport over 1,200 pounds of cargo to the International Space Station, including science experiments, food, water, and clothing for the astronauts, and even a laptop computer and its accompanying accessories will make the journey. Dragon will spend about 1 week attached to the space station, and over that period of time, the astronauts will spend a total of about 25 hours unloading the cargo. They will then load over 1,300 pounds of equipment and expended consumables aboard the Dragon to be brought back to Earth. Dragon is actually capable of carrying up to 7,300 pounds of supplies to the space station. Once in orbit, Dragon will have a link with a network of ground tracking stations around the world, as well as with NASA's tracking and data relay satellite system. For its return, approximately 4 hours after Dragon leaves the station, Dragon will conduct its deorbit burn, which lasts about 7 minutes. It then takes about 30 minutes for Dragon to re-enter the Earth's atmosphere and then splash down in the Pacific Ocean about 250 miles off the coast of California. We're about 2 minutes away from going into the final configuration for launch for the Falcon 9. We're at T-minus 41 minutes, 37 seconds and counting. This is Falcon Launch Control.
T-minus 40 minutes.
GC, are you ready for the vehicle release setup auto sequence?
GC is ready.
Copy that. Entering 1, proceeding. Vehicle release final setup is started. CE, prepare for the terminal count poll.
In work.
Copy that. Entering 1, proceeding. CTEP vent has ended nominally.
S2 fuel bleed has been performed. VC, you can skip.
Copy that. LC entering 0, skipping S2 fuel bleed. Dynamics data setup has started.
And we have verified the flight hazard roadblocks are in place.
Copy that, LC. Proceeding.
We do not need a supplemental weather briefing.
Copy that. Entering 0 to skip. RC, report the downrange tracking station status.
Ready to proceed.
Copy that. Proceeding. Rock VC on countdown 1.
Rock.
Rock, report range status.
Range status is proceeding.
Copy that. GNC, verify winds aloft are acceptable for loads and control authority, and verify ground winds are within launch limits.
Winds aloft are acceptable and ground winds are within limits.
Copy that. Proceeding. Flight software, verify consoles have no critical errors.
Verified.
Copy that. Proceeding.
VC, this is LC. All previous steps are complete in the procedure and all previous items have been performed.
Copy that. Proceeding within Yoda.
This is Falcon Launch Control, T-minus 33 minutes and counting. We're going to go out to the International Space Station Mission Control Center in Houston for an update on the readiness of the space station and Houston to support the activities after launch tonight. We'll go now to Mission Control and Brandy Dean at Johnson Space Center.
Thanks, George. Good morning and welcome to Mission Control Houston, where the team here in the International Space Station Flight Control Room has been following along with preparations for tonight's launch and anticipating the planned demonstrations that will hopefully lead to the first docking of a commercial vehicle to the International Space Station on Friday. Leading the team here at the Johnson Space Center is Tony Sakachi, the Orbit 1 flight director for today. However, assuming all goes as planned this morning, Holly Ridings, the lead NASA flight director for the SpaceX demonstration mission, is going to be taking over once the Falcon 9 gets off the ground. You can see both Holly Ridings and Tony Sakachi in this view, along with the Capcom for today, Jill Lindgren. In preparation for today's launch, the team here in Houston has already given their go for launch after a go-no-go poll here in the room that verified that all the systems that would be used for docking are indeed ready to be called into action, and that the ground network connections used to connect Mission Control in Houston with the SpaceX team in Hawthorne, California are in good order. This launch and the upcoming docking of the Dragon capsule to the International Space Station are the product of many years of preparation on both NASA and SpaceX side, and the two groups are prepared now to function as one team. Waiting the Dragon and its cargo, some 1,014 pounds of food, clothing, and supplies in space, is the newly expanded Expedition 31 crew. That's Commander Oleg Kononenko and flight engineers Don Pettit with Andre Kuipers. They've all been anticipating and preparing for the Dragon's arrival for some time, and they were recently joined early Thursday morning by new crewmates Gennady Padalka, Sergei Revin, and Joe Akaba, who've made it just in time to witness the historic event firsthand. In fact, the crew is expected to be in range of video downlink at the time of the launch, and the team here in Mission Control will be sending the video up to them to watch live. At that time, the International Space Station will be about 249 miles above the North Atlantic Ocean, east of St. John's, Newfoundland, at the time of the Falcon 9 launch, which is coming up in just 30 minutes now. Once it has landed, of course, the Dragon capsule will begin its journey to the International Space Station and perform a series of tests as it makes its way there to prove that it will be able to dock safely with the station when the time comes. Over the course of today and tomorrow, the vehicle will verify that its absolute GPS system works and demonstrate its ability to float freely in space with its thrusters inhibited and move away from the station if necessary. It'll come into the station's vicinity for the first time on Thursday for its fly under test, in which it will establish communication with the station, test its relative GPS system, and allow the crew to send its first command to the Dragon, turning on its strobe light to ensure that it does in fact receive commands from the crew. And then, assuming these and a final series of tests go well, the teams here on the ground feel comfortable with the Dragon's performance. Friday is going to be the docking day. That's scheduled now for 10:05 a.m. Central Time and will be performed using the space station's 58-foot-long robotic arm by flight engineer Don Pettit with help from flight engineer Andre Kuipers. They'll use the arm to grab onto the Dragon once it's at a point 32 feet away from the station, and then bring it in for berthing to the Earth-facing port on the station's Harmony node. The crew has been practicing for this task since before they left Earth in December. From there, it'll be just a matter of opening the hatches between the Dragon, and the crew will begin the work of unpacking its cargo and then repacking the cargo to send back to Earth. That task is scheduled to take about 24 hours of crew time in all. So we'll be looking forward to all of that here in the International Space Station Flight Control Room following this morning's launch. Now just 28 minutes away. This is Mission Control Houston, and back to you, George.
We're back at the SpaceX Falcon 9 Launch Control Center, where the Falcon 9 rocket is about 8.5 minutes away from going into final countdown preparations for a liftoff at 3:44. The Falcon 9, as we see it on the pad there, is 157 feet in length, 12 feet in diameter, and weighs 735,000 pounds. 9 SpaceX Merlin engines power the Falcon 9. The rocket is held down on the pad and not released for flight until all propulsion and launch vehicle systems are confirmed to be up and running properly. Then after liftoff, the first stage will burn for 3 minutes before separating from the rest of the rocket. A single Merlin engine on the second stage will burn for 5 3/4 minutes before the Dragon separates from the Falcon 9, 9 minutes 35 seconds after launch. After the liftoff, mission control for the Falcon 9 and the Dragon spacecraft will be at the SpaceX Mission Control Center in Hawthorne, California. Dragon will have a link with a series of ground tracking stations around the world, and also will be using NASA's Tracking and Data Relay satellite system. During the Dragon's approach to the International Space Station, NASA Space Station Mission Control in Houston will be involved in the approach and berthing activities. At the time of the launch, the International Space Station will be located 249 miles above the North Atlantic Ocean, east of St. John's, Newfoundland. At T-minus 26 minutes, 53 seconds and counting, this is Falcon Launch Control.
T-minus 25 minutes.
This is Falcon Launch Control, T-minus 23 minutes and counting. In about 3 minutes, we'll begin our final countdown launch preparations. We'll hear our SpaceX launch conductor Brian Childers running through that checklist and giving final instructions to the launch team. The final readiness poll comes at T-minus 13 minutes. Shortly after that, at about T-minus 9 minutes 43 seconds, they'll begin chilling the 9 first-stage Merlin engines, and then the Dragon capsule goes to internal power at T-minus 8 minutes. The Falcon 9 rocket goes internal at T-minus 4 minutes 46 seconds. Shortly after that, the flight termination system will be armed at T-minus 3 minutes, and the LOX topping will be terminated, ending the flow of liquid oxygen to the rocket.
Copy that.
And at T-minus 2 minutes and 30 seconds, we'll hear our SpaceX launch director, Brian Mosdell, give the go for launch. Standing by now in about a minute and a half, and we'll hear the team begin their final launch preparations for liftoff at 3:44 a.m. this morning. Launch is on schedule, weather is green, and we're working no issues. At T-minus 21 minutes, 23 seconds and counting, this is Falcon Launch Control.
T-minus 20 minutes.
This is the CE on countdown. Falcon 9 and Dragon are ready to launch.
Copy that. CE proceeding within IOTA. CE, save current LCCs to disk.
Stand by.
Copy.
And complete.
Copy that. Proceeding within IOTA.
This is Falcon 9 launch control, T-minus 16 minutes 40 seconds and counting. Continuing to move toward our terminal countdown sequence. We'll get a readiness poll at T-minus 13 minutes for the launch team. The Dragon spacecraft will separate from the Falcon 9 9 minutes and 49 seconds after the liftoff. And then the solar array deployment starts 11 minutes 19 seconds after launch and takes roughly half a minute to complete. Still working, no issues. Range is go. Cape weather is go. At T-minus 50 minutes 53 seconds and counting, this is Falcon launch control.
This is the LC on the countdown net. Stand by for the final poll at T-minus 13 minutes per step 57.2 of the procedure. T-minus 14 minutes.
LC, execute final test launch preparations per procedure 1.160 at T-minus 13 minutes.
Copy.
Copy that, proceeding.
All stations verify ready for launch. All stations acknowledge. FTS.
FTS go.
Prop.
Props go.
AVI.
AVI go.
GNC.
GNC go.
Ground.
Ground is go.
VC.
VCs go.
GC.
GC's go.
DC.
DC's go.
RC.
RC's go.
OSM.
OSM go.
ROC.
Range is ready.
CE.
CE go.
LD.
Launch director go.
MD.
Mission director go.
LD, verify go to initiate terminal count.
LC, you are go to initiate terminal count.
Copy. Proceed. T-minus 12 minutes.
GNC, prepare for the final print INAV command.
GNC ready.
Copy that, proceeding.
This is Falcon 9 launch control, T-minus 11 minutes, 35 seconds and counting, preparing to go into the automatic launch sequencer, the computer launch sequence starting at T-minus 10 minutes. We'll get a final go from the eastern range at 2 minutes, that all downrange tracking stations are go and that range safety is go.
VC, start the terminal count auto sequence set to start at T-minus 10 minutes.
Proceeding. Dragon terminal count and terminal count launch have started, and they will continue at T-minus 10 minutes.
If a hold is called from this point forward, the terminal count auto sequence will be aborted. Indicate an abort or hold condition by verbally saying hold, hold, hold on the primary countdown net. In this event, VC will immediately abort the idle sequence. VC shall not abort the idle sequence after T-minus 10 minutes, T-minus 10 seconds, and operator shall not call a hold after T-minus 15 seconds. Attention all personnel, stand by to pick up the count at T-minus 10 minutes and counting on my mark. Three, two, one, mark. VC announced the sequence has started.
Dragon terminal count and terminal count launch have started.
RCO confirmed clock is counting. GCVC standby on FireX.
Standing by. Standing by.
OSM sent launch enable to flight.
Switch into flight.
RCO confirmed clock is counting.
Clock is counting.
Pre-valves are coming open. Aux bleeds are open. The M9 engines are chilling in.
Pre-valves are open for flight.
T-minus 9 minutes. T-minus 8 minutes.
Dragon going to internal power. Next step is to command the flight computer to begin alignment.
T-minus 7 minutes.
First stage fuel bleed open. Vehicles in self-alignment.
T-minus 6 minutes.
Stage 2 TVC bleed has started.
T-minus 5 minutes.
Vehicle and pad abort systems are setting up for launch. GN2 load has ended. Stage 1 and Stage 2 internal auto sequences have started.
We're on internal on Stage 1 and Stage 2.
Now turning on the telemetry and video transmitters.
Vehicle release auto sequences started in preparation for launch.
T-minus 4 minutes.
Ground T-tib system setting up for launch.
FTS on internal power.
S2 TVC complete.
Pre-valves are coming closed.
T-minus 3 minutes.
FTS is armed.
LOX load is ending nominally. Fuel trim valves are in their flight positions.
LD, verify go for launch.
Launch directors go for launch.
Stage 2 heaters is ending nominally.
Rock, verify range go.
Range green.
Pre-valves are coming open for one last chill. Helium load is ending nominally. Purge ISO is opened.
First stage engines are chilled in.
The flight computer will be commanded to a startup state in about 5 seconds.
Vehicle is in auto idle.
T-minus 1 minute.
Vehicle is in startup.
The flight computer is in control of the vehicle.
Tanks coming up to flight
Stage
pressure.
1 and Stage 2 tanks are pressing to their flight pressures.
T-minus 30 seconds.
All propellant tanks at pressure.
T-minus 20.
Fire X is on.
T-minus 15 seconds.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And launch of the SpaceX Falcon 9 rocket as NASA turns to the private sector to resupply the International Space Station.
Starting gravity turn. First stage engines at full power, looking good.
We have a solid telemetry link and the power systems are nominal.
First stage propellant utilization is active. Vehicle's on a nominal trajectory. Altitude 5.3 kilometers, velocity 225 meters per second, and downrange distance of 0.6 of a kilometer. Vehicle is supersonic. Vehicle has reached maximum aerodynamic pressure. Propulsion's performing nominally, starting stage 2 engine chill.
We have a solid RF link and power systems are nominal.
Vehicle's on a nominal trajectory, 30 kilometers altitude, 1 kilometer per second velocity, and downrange distance 20 kilometers. Dragon power systems are nominal. Vehicle's on a nominal trajectory, 53 kilometers altitude, 1.7 kilometers per second velocity, and downrange distance of 51 kilometers. Approaching MECO 1. MECO 1, planned shutdown on engines 1 and 9. First stage impact point past mid-MECO. MECO 2. Nominal velocity at MECO.
Stage set confirmed.
And deck ignition confirmed.
The Dragon nose cone has been jettisoned.
Stage 2 propulsion systems nominal.
Vehicle remains on a nominal trajectory, 176 kilometers altitude, velocity of 3 kilometers per second, downrange distance 320 kilometers.
And power systems are nominal, and we still have a solid telemetry link.
OSM, this LC, please move to Net A.
Stage 2 propellant utilization is active.
Vehicle remains on a nominal trajectory, 220 kilometers altitude, 3.4 kilometers per second, and downrange distance of 470 kilometers.
Second stage propulsion performing as expected.
Second stage power systems looking good, and we have a solid telemetry link.
Vehicle remains on a nominal trajectory, 269 kilometers in altitude, velocity of 4 kilometers per second, and a downrange distance of 712 kilometers.
MVAC and stage 2 performance is good.
Vehicle remains on a nominal trajectory, 300 kilometers in altitude, velocity of 5 kilometers per second, and downrange distance of 1,000 kilometers. IMU sensor remains healthy, and GPS lock is verified.
And we are picking up data from New Hampshire.
Vehicles in terminal guidance. Vehicles pass through the European gate.
FTS is saved.
MVAC shutdown confirmed.
Falcon 9 and Dragon are in orbit.
Dragon is in separation state.
Wait.
Apogee 346 kilometers, perigee 297 kilometers.
And the
1.66 degrees.
Cameras forward.
solar array deployment should start in about a minute.
Start of payload settling deploy.
.30 seconds from solar array deployment.
Dragon solar array deployment has started. Solar arrays have deployed.
LD, MD on countdown.
LD's on a phone call right now, MD.
Yeah, copy that, LC. We're going to be switching off countdown net. Thanks for the ride.
Okay. Good luck.
Dragon has started its attitude and maneuver towards Tetris.
This is Falcon 9 launch control, 14 minutes, 14 seconds into the mission. So arrays have deployed. The initial planned orbit in miles is 193.7 by 212.5 at an inclination of 51.6. And the apogee, or the high point of that orbit, is just below the ISS by about 37 miles. We're going to go out now to the International Space Station control room in Houston for an update from commentator Brandy Dean.
Thanks, George, and welcome back to Mission Control Houston, where all eyes of the International Space Station Flight Control Team have been focused on the views of the launch of what will hopefully in just a couple of days become the first commercial vehicle to dock to the International Space Station. With the Falcon 9 successfully off the ground, Tony Sakachi, the Orbit 1 flight director, has now handed control of the room over to Holly Ridings, NASA's lead flight director for the SpaceX demonstration mission. She'll be here for the next several hours, and of course will be coming back for the next several days as the Dragon makes its way to the International Space Station. At the time of today's launch, the International Space Station was 249 miles above the North Atlantic Ocean east of St. John's, Newfoundland, with a newly expanded Expedition 31 crew of 6 on board. They are Commander Oleg Kononenko and flight engineers Don Pettit and Andrei Kuipers, along with Gennady Padalka, Sergei Revin, and Joe Akaba. The crew's been awake since 1 a.m. Central Time and was able to watch the launch in real time aboard the station. They're now going through their morning daily planning conference. The crew is also going to be paying attention over the next 2 days as the Dragon spacecraft makes its way to the International Space Station for a possible docking at 10:05 a.m. Central Time on Friday. Between now and then, however, the Dragon has several demonstrations and tests to go through to ensure that it will be able to dock safely to the International Space Station. Those are going to start with the demonstration of Dragon's absolute GPS system using global positioning system satellites to determine its location. And the spacecraft will also conduct a free drift demonstration to allow the spacecraft to float free with all of its thrusters inhibited and perform a demonstration of its abort capability to ensure that it can move away from the station if necessary. This has all been tested on the ground and verified by NASA, but it will now be validated on orbit before the systems are used in safety critical situations near the space station. Assuming that all goes well, the Dragon could then be given a go to approach the International Space Station for the first time on Thursday. Coverage of this fly-under test is scheduled to begin at 1:30 a.m. Central Time on Thursday. And over the course of several hours, the Dragon will perform a series of burns to bring it to a point 1.5 miles below the space station. There it's going to establish communication with the station and perform a test of its relative GPS system, which uses the relative position of the spacecraft to the space station to determine its location. And then the crew will get its first chance to command the Dragon. They'll be turning on a strobe light on board the Dragon from the space station to verify their ability to send commands to the vehicle. That's going to be important on Friday when it's time for them to bring the Dragon in for docking. Once those fly-under tests are complete, the Dragon will fire its engines to begin a loop around the space station at a distance of 4 to 6 miles and get set up for its chance to re-rendezvous with the space station on Friday. Again, assuming all goes well, on docking day, the Dragon will again move into position 1.5 miles below the station, and if the go is given by the team here in Mission Control Houston, a burn will be performed to bring the vehicle within less than 1 mile of the station. Then there will be another no-go decision in Mission Control before it moves into 820 feet for another demonstration, this one of its LiDAR system, which will confirm the Dragon's position and velocity is accurate. For that, the flight control team in Hawthorne is going to command the Dragon to approach the station and then move 720 feet away, and then the crew on board of the station will command it to retreat. The flight control team will then send it back to the station, and at that time the crew will allow it to hold its position through another command. At that point, there will be another go-no-go poll before the Dragon will finally get into the imaginary keep-out sphere around the station. Then the vehicle will get within 100 feet of the station and hold for another go-no-go before it finally moves into position for capture by the space station's robotic arm just 32 feet away. Capture itself is going to be performed by Flight Engineer Don Pettit with help from Flight Engineer Andrei Kuipers. They'll be using the station's 58-foot long robotic arm to grab onto the Dragon and guide it to the Earth-facing port of the Harmony node. The capture itself is scheduled for just after 7 a.m. on Friday, with the docking again scheduled for 10:05 a.m. Hatch opening will then take place on Saturday, with the crew beginning the 25 hours of unpacking and then repacking work to do before the Dragon leaves the station later this month. All that's coming up over the course of the next week, so stay tuned to NASA TV and visit nasa.gov for updates. This is Mission Control Houston. Back to you, George.
We're now at 19 minutes 28 seconds into the flight of the Dragon capsule after a successful launch of the Falcon 9 rocket. The official launch time was 3:44:38 a.m. Eastern Time. Right now we are going to go through some of the launch replays from our tracking cameras around the Cape and onboard cameras. So we will return for a brief conclusion and summary of our operation after we go through our launch replay sequence. We're now 34 minutes, 20 seconds into the flight of the Falcon 9 and the Dragon capsule, which is now on orbit with the solar arrays deployed. We're looking at a live picture of the SpaceX Mission Control Room in Hawthorne, California, from where the capsule is now being controlled. Our next event will be a post-launch news conference, which will be held just over an hour from now at 5:30 a.m. Eastern Time, live from the Kennedy Space Center. This will conclude our launch coverage of the SpaceX Falcon 9 rocket at 35 minutes, 3 seconds into the flight of the Falcon 9. This is Falcon 9 Launch Control.